Well, they say you can't spell functions without fun, and ain't that the truth? It is. It is the truth. I'm telling you right now, I'll answer that for you. It is the truth. What's not the truth is the fact that I'm having a hard time pressing that button. Functions, packet 5. A function is a function if every x is mapped to exactly one y value. Also, the domain is mapped to exactly one y value. In other words, x's can't repeat. The x values, the domain values, the input values cannot repeat. So a function is a function if the x values do not repeat. So let's take a look at all of these. For this guy, I have x is -1, that goes to one thing. X is 0, that goes to one thing. Now, I don't care that -1 and 0 go to the same thing. -1 itself goes to one thing and 0 goes to one thing. 1 goes to one thing, 2 goes to one thing, 8 goes to one thing. Is this a function? Yes, it is. And it is a function. Wow. That looks terrible. It is a function because I know why it looks terrible. I grabbed the wrong pen. It's a function because every x value goes to exactly one y value. So let that be the answer to problem 1. As I'm getting a pen from my backpack, let's take a look at 2. 2, the middle one, we'll see if any of the x values repeat. So I have the points 3, 4, 6, 1, -7, 4, and 3, 8. I see repetition in the x values. I dropped it. I dropped my stylus. We're ready. All right. These 3 values repeat right there and right there, which means this is not a function, and it's not a function because the x values repeat. If that looked like a mapping diagram, you would see something like this going on. This is bad. You don't see that happen in this problem here on the left. This problem here on the right, what you have is x is 4, x is 5, x is 6. They all go to 8, but I don't care what y's look like. It's the x values that are not allowed to repeat, so this is a function. And much better handwriting than the one all the way to the left. All right. New concept. If you see something like this, this is called function notation. F parentheses x. That is not f times x. You say it as f of x. And all that means is we care about x, and this is the function where we care about x. That's all it means. If you see f of 3, that just means you plug in 3 for every x. Plug in 3 for every x. So that's not f times 3, that's f of 3. And you'll see that at the beginning of an equation instead of y. F of x is the same thing as y. F of x is the same thing as y. F of x is the same thing as y. F of x is the same thing as y. So let f of x equals 2x minus 1 and find f of -5. Well, f of -5 means I'm going to plug in -5 for every x value. So 2 parentheses -5 minus 1 is the same thing as 2 times -5, which is -10, and -10 minus 1 is -11. So f of -5 is -11. If f of x equals x squared over 2 plus 7, and I'm supposed to find f of 4, then f of 4 is going to look like 4 squared, a game, over 2 plus 7. PEMDAS says we do parentheses or exponents first, so I'm going to do 16 over 2. Whoa, that looks like a terrible over, but it's an over. 16 over 2, which is 8. And 8 plus 7 is 15. So f of 4 is 15. Now, of course, you could do all this in a calculator, but we'll do calculator stuff later. Let me throw a little vocab at you. The domain. What is the domain? I already said those words before earlier in the video. Domain's the x values. The range will be the y values. Simple. Simple. You just have to remember which is which. Domain is also called input. Range is also called output. Well, it depends on, who makes the problems and stuff like that. So the domain in this case is going to be 3, -2, and 6. The range in this case is going to be 6, 6, and -7. But I'm only going to write out 6 and -7 because what's the point of repeating myself? I'm not going to. Let me see. I'll zoom up a little bit on this one so I have the space. There we go. The domain for this one, which, by the way, this is not a function because the negative ones and the regular ones in the domain repeat. But the domain is -1, 1, 2, 4. The range is 1, 2, 3, 4. There's my domain. There's my range. Not a function. This guy is also not a function, and we will talk about that on the bottom half of the problem. But this is weird. The domain's all the x values, and the x values seem to be covered between that 2 and that 6. So we will write the domain out as everything in between 2 and 6, and this is how we write out everything between 2 and 6. Or you could just say the phrase everything in between 2 and 6. The range is all the y values being covered. So that's u up to u. And so we will say everything in between 1 and 5. The domain is all the x values being covered in this picture, which is a function. We will talk about that y in a minute. But if this picture were to keep going, it would forever go out left and forever go out right. So the domain is going to be all real numbers. We'll just say all numbers because my face is in the way. All numbers. The range, however, starts from here and goes downwards. So it's basically all of the negatives, and we'll just say the range is going to be y is equal to or less than 0. Okay? Now, when I said here that this is going to be, this one on the left is not a function, but the one on the right is, how do I know that? Well, the vertical line test tells us that. So let me move my face over here. I'm moving my face everywhere. The vertical line test. Vertical line test. Remember, vertical means up and down. Determines if a graph is a function. If a vertical line passes through a graph more than once, it is not a function. If a vertical line passes through a graph more than once, it is not a function. So what I'm going to do is I'm going to draw a vertical line. And if at any time this vertical line, perfect vertical line here, passes through my graph more than once, it's not a function. So beep, 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 beep. Not a function. Draw a better vertical line, much better. Beep, 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 beep. Ooh. Beep, 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 beep. Ooh. The old beep, beep test never fails. See, every time I run my red line through the graphs, it's only touching the red graph once. Let's see if that happens over here. Beep, 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 beep. I'm not going to scream because people in the other room are taking tests. So not only does it hit the graph more than once, it hits it 3 times. No. That's the vertical line test. And I believe that's it for the page. Yep. So let's practice. All right, here we go. A 20-minuter. Let's see how long it takes us. Which set of ordered pairs is a function? Well, the x's can't repeat. So we need to pick the one where the x's don't repeat. So 1.6 is an x, 1.4, 1.4. Nope, you're not a function. 0.3, 0.2, 0.3. Nope, you're not a function. -2, -2, -2. Nope, you're not a function. 4, 1, 8. Yerp. I'm not even caring about the y's. I don't care about the y's. It would be wise for you not to care about the y's. Okay. Oh. Which relationship could be shown by the graph? Now, without even looking at this or at the options, we're talking about pages and days. So maybe someone's reading, and it looks like every day they read about 15 pages. Every day they read about 15 pages. So let's see if that's an option that we have. The number of pages Joyce reads if she reads 15 pages each day. Okay. The number of days it takes Joyce to read a book if she reads just 20 pages a day. Nope. The number of books Joyce can read if she reads is 5 books a month. Nope. The number of weeks it takes Joyce to 5. Well, no. So was I. Worded strange. Answer, not so much. Which table below contains points shown on this graph? So let's label a few points. And they want you to put it in a chart. So we're going to label a few points and scratch out the ones that don't seem to make sense. So they are using XY charts. So we have, here's a point, here's a point, here's a point, here's a point. So I've got -2, 2. I've got -1, 0. I've got 0, -2. And I'm out of room. So let's see which ones seem to fit that description. -3, 3. I don't know. -2, 2. Yeah, -1, 1. Nope, it's not A because it's supposed to be -1, 0. So cross out A. -1, 0, 2, 0, -2, 2. It's possible, but I'll tell you what, 2, 0 is this point right here, which is not on the line, so it can't be C. Can't be C. Impossible. Excuse me, face. Excuse me, face. Excuse me, face. -1, 0, check. 0, -2, check. 1, -4. 1, -4. Yep, it's B. So, I don't know. I started out by just making points, but it was probably better if I just used my answers first to see which one seems to make the most sense. Which rule is true for all of the pairs and the values of each table? All right. I'm going to use Linreg. You don't have to use Linreg, but I'm going to use Linreg, which is a calculator method to do these. Okay, I'm going to quick rewrite these points in a vertical form. So I have X and Y. My X values are -2, 0, 2, 4. My Y values are -5, -1, 3, and 7. This is how you use Linreg. Start out by hitting Stat. Go to Edit. I'm going to type out all my X values in L1. So -2, enter. 0, enter. 2, enter. 4, enter. I'm going to go to the right. I'm going to type out all my Y values in L2. So my Y values are -5, enter. -1, enter. 3, enter. 7, enter. Make sure all your values match up. So like -2 matches up with 5. Yep. 0 matches up with -1. Yep. 2 matches up with 3. Yep. 4 matches up with 7. Yep. All the X's are on the left. Yep. All the Y's are on the right. Yep. Now this is what we're going to do. We're going to quit by doing second mode. Takes us to our home screen. We're going to go back to Stat. And like I said, we're going to do Linreg. So go to Calc, which means you go right once. go down to 4 or hit the number 4, which I'll do, and it's going to ask you to hit enter a bunch of times. So I'm going to hit enter, 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 enter. And it tells me that y equals ax plus b, where a is 2 and b is -1. So if y equals ax plus b, well, if a is 2, then y equals 2x plus b. But if b is -1, plus -1 is the same as -1. Now, some of you might be like, I would just rather plug in -2 into all of these and see which one gives me -5, or and then just whatever. I'm just going to do Linreg because I can, and I'm probably going to do Linreg several more times during this video. So, tough. All right, so this second page, just by a quick glance, it looks like we have a lot of Linreg again, which is fine. And Linreg is not 100% necessary. Like, you could look at this chart, and maybe by looking at this chart, you could figure out patterns, and a pattern is slope. And maybe I'll show that once, but let me actually do that. Let me show you how I could use the pattern to be slope, and then I'll remind you what to do for this guy and for that guy, Linreg. Linreg's very important. You're probably going to use it a lot. But let me write out, this is asking for the relationship between y and x, which means, slope-intercept form. So y equals mx plus b. M is your slope. The slope is the change in y over the change in x. So the change in y seems to be saying up 4. I add 4 every time I change y. And I add 1 every time I change x. So it looks like my slope is going to be 4 over 1. That's my slope, is 4 over 1, also known as 4. I have my answer. The y-intercept is going to be the point where x is 0. Oh, look, x is 0 and y is 1, which means 1 is my y-intercept. 4 is my slope. 1 is my y-intercept. The answer is D. How can we do this, though, using Linreg for the 50th time? Well, let me show you. Hello, calculator. Second plus 712 clears everything. Go to Stat. Go to Edit. Put your x values in the left column. So -1, enter 0, enter 1, enter 2, enter 3, enter. Put your y values in the right column. -3, enter 1, enter 5, enter 9, enter 13, enter. Make sure everything matches up, and it looks like it does. When you're done, second mode quits. Go to Stat. Go to Calc, Linreg. I'm going to hit Enter a bunch of times until I get to calculate. Y equals ax plus b. A is 4, b is 1. So y equals 4x plus 1. Okay. A function t pairs with a real number with its opposite. Which ordered pair belongs to this function? Well, opposite just means one's positive and one's negative. So it's A. That was easy. Which set of number completes this function table for the equation below? Well, why don't I get my calculator out and make a function table? This is y equals half x plus 4. So I'm going to type out y equals half x plus 4. I want to check out a function table, so I'm going to go to Table, which is second graph. I can go up a few times. When x is -2, y is 3. When x is 0, y is 4. When x is 4, y is 6. So I need 3, 4, 6. A is 3, 4, 6. A. Hey, it's my stereotypical New Yorker accent. Hey, I'm walking here. Forget about it. Hey. All right. Well, looks like it's Linreg again. Anytime it gives you a bunch of points and you need an equation, use Linreg. So I'm going to use Linreg. If I hit stat edit, I'm going to see a bunch of points there. So second plus let's try that again. Second plus 712 clears everything out. So stat edit. I'm going to put my x values in the left. It's out of order. No big deal. I'm going to put my x values on the left. So 15, enter, 30, enter, 5, enter, 25. And if you're like, do I have to put it in order? Nope. You just have to make sure that 15 goes to 3. You have to make sure that 30 goes to 6. 5 goes to 1. And 25 goes to 5. Second, mode, stat, calc, Linreg, enter, 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 and there it is. Y equals 0.2x plus 0. Well, wait a minute. None of these say 0.2. Oh, I know what I can do. I could turn a decimal into a fraction by doing this. 0.2 math frac 1/5. So this is the same as 1/5 x. Well, wait a minute. 1/5 x isn't there either. Oh, 1/5 means to divide by 5. So 1/5 x means divide by 5. Now let's just play the common sense game. You're like, some of you who are like, you did too much. Because it looks like the way I get from 15 to 5, the way I get from 30 to 6, the way I get from 5 to 1 is I just take the x value and divide by 5. There it is. Duh. And that's right. And some of you may have noticed that, like, dummy, the way I get from x to y is I multiply by 4 and add 1. 1 times 4 plus 1 is 5. 2 times 4 plus 8 is 8 plus 1 is 9. 3 times 4 is 12 plus 1 is 13. That's why this makes sense. Because what these equations are telling you to do is, hey, take that x value, do this to it, and you'll get a y. So if you're like, well, if it's multiple choice, I'm just going to use common sense and do it that way, which is fine. But I'm just showing you guys Linreg anyway, because why not? Just more stuff that you can use. All right. Which graph shows a function? Remember, if I give you a graph and I ask you to make sure if it's a function, it has to pass the vertical line test. So if I run a vertical line and the vertical line hits the graph twice like it does here, beep, 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 it is not a function. So it's not C. If I take a vertical line and I run it through my graph, and it only hits the graph once, so beep, 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 beep. I'm good. This fails here. Beep, 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 beep. See how it hits the 2 dots? Beep, beep, beep. And it fails 3 times here. Beep, beep, beep. So if it fails the vertical line test, it is not a function. So it is not you, and it is not you, which means it's, as Soulja Boy would say, you. Gotcha. So I could do Linreg here, but I won't. I'm going to use common sense. Let me see. What do I do here? In order to get B, so it's always going to be whatever this letter is. It's usually Y, but in this case, it's B. It's always going to be B equals. Always going to be B equals. So I'm going from 1 to 6, from 2 to 11, from 3 to 16. So probably multiplying by 5 and adding 1. 1 times 5 plus 1 is 6. Yep. 2 times 5 is 10 plus 1 is 11. Yep. So it is times 5 plus 1. So I'm taking my A value and I'm multiplying 5. So it's 5A. And I'm adding 1, which is A. If I did Linreg, it would tell me y equals 5x plus 1. And then you would have to be like, okay, well, A is x and B is y. So replace the A with x and replace the B with y. Some of you might say, well, in another problem, Mr. Parrish, you did patterns. And you notice that every time this goes up by 1, this goes up by 5, which means my slope is 5. And only one of these have a slope of 5, and it's A. Lots of different ways to do it. Lots of different ways to do it. All are fun. Which table gives the ordered pairs for the graph of a nonlinear equation? If it's linear, it makes a straight line. If it's a straight line, it follows a pattern. So we need the one that breaks the pattern. Okay, so A, the left side, boop, 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 goes up by 1. No, it doesn't. No, it doesn't. This goes down 2, stays the same. So it's going to be A because the A doesn't have a pattern. Let's look at the others just to make sure that we're good. B is up 2, up 2, up 2. That's a pattern. Up 1, up 1, up 1. That's a pattern. This one's linear. Up 1, up 1, up 1, that's a pattern. Up 1, up 1, up 1, that's a pattern. That's linear. Up 2, up 2, up 2, that's a pattern. Up 4, up 4, up 4, that's a pattern. That's linear. So the reason why it's A is nonlinear doesn't follow a pattern. This is up 1, skip a bunch, up 1. This is -2, stay the same, up 2. That's not a pattern. So A is the nonlinear one because it doesn't follow a pattern. Linear means line, and a line is a pattern. A function is in the form y equals mx plus b. Oh, that doesn't have anything to do with this here. Okay, so let me get my calculator out again. Whenever it says, hey, which ordered pair, blah, 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 you're going to take your calculator. Remember what we said. Anything of x is the same thing as y. So I'm going to go to y. I'm going to type out 2x. Here's my squared button. Plus 5. I want to see which point lives on this guy. So I'm going to go to second graph to take me to a table. And let me see, is it 311? Let's go down to 3. Is it 311? No. Is it 11.3? No. Is it 317? No. Is it 323? Yes. So the answer is 323. Another way I could check that is I could plug 3 into x and do PEMDAS. 3 squared is 9, times 2 is 18, plus 5 is 23. Which set of ordered pairs is a function? If it's a function, the x's don't repeat. So -1, 0, 1, 0. Oh, look, x's repeat at 0. It's not A. -1, 0, -1. The negative ones repeat, so it's not B. Remember, x's can't repeat for it to be a function. -1, 0, 1, 2. The x's don't repeat. That is a function, but let's just double check D. -1, 0, -1 is used twice. So since -1 is used twice, that's not a function either. Mapping diagram. Which ordered pair is a member of the relation shown in this mapping? All right, so like 1 goes to, or 0 goes to -2. 1 goes to 0. 5 goes to -3. 5 goes to -2. So like there's 5 points here. 0 goes to, there's 5 points here. 0 goes to -2. 1 goes to 0. Uh, 5 goes to -3. 5 goes to -2. So this isn't a function. It's not asking that, but I'm just throwing my 2 cents. And 10 goes to -1. So let me see. -3, 0, nope. 0, -2, yup. 1, -1, nope. -3, nope. Okay? Easy. It's easy. Which number completes this table? All right, well, let's find our pattern. Add 1, add 1, add 1, add 1. -2, -2, -2. So 0 minus 2 is -2. And -2 minus 2 is -4. Let's find your pattern. Okay. Linear means it's in the form y equals mx plus b. I know I accidentally said that for 12 and was like, oh, I didn't need that, but there you go. Y equals mx plus b. Okay. Now, none of these are in that form. But you know what we don't see in y equals mx plus b? Squareds. Squareds. And you know what we don't see in y equals mx plus b? X divided by y. So if I subtracted x from both sides for b, I would get y equals -x plus b. Which is that? Which graph is not a function? Not a function. All right, so straight line. Doot, 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 doot. You're good. Doot, 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 doot. You're good. You're not the function. I've heard of not the mama, but not a function. Dinosaurs. It's a TV show from the 90s. Terrible. Terrible TV show. Hated it. Lots of people liked it, though. I just didn't think it was that great. All right, last page. Last page. Which equation shows a relationship between x and y? Let's just do Linreg one more time. Or maybe 2 more times, because I see a table right underneath it. I want to clear everything. So, second plus 7, 1, 2. Stat. Edit. -1, enter. 0, enter. 1, enter. 2, enter. 3, enter. -2, enter. 2, enter. 6, enter. 10, enter. 14, enter. Make sure everything is where it should be, and it is. Second mode quits. Go to stat. Go to calc. Go to Linreg. Enter, 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 enter. Y equals 4x plus 2. And again, that makes sense because this goes up by 1. This goes up by 4, which means your slope is 4. And if you're like, my slope is 4, but I have several of these with a slope of 4. What about the y-intercept? Y-intercept exists when x is 0, so my y-intercept is positive 2. Bing bong. Which rule was used to make this table? Divide by 2. Pretty easy. Which graph is a nonlinear function? Well, linear means line. So which one is nonlinear? Let me see. You're align, you're align, you're align, you're not. So that was pretty easy. And according to the little sign on the top right, oh, we done. So that's packet 5, ladies and gentle kids. Fun, always. But that's packet 5 of packet 8. Move on to packet 6. Bye!